Hi, in this video we're going to talk about chapters 14, chapters 15, river systems and landforms. Fluvial refers to water in motion over the land. So we're going to talk about streams and rivers in this particular case and get more into erosion, which is the production of weathered sediment and essentially the movement of it from one place to another. It involves transportation, deposition, and alluvium, which is basically sand, silt that is transported by river processes. It gets pulled or moved by gravity. Okay, so higher elevation to lower elevation. We have something called the drainage basin. So a drainage basin is a spatial, geomorphic unit that's occupied by a stream system. And it's formed by ridges and basically by elevation. So I like to explain a drainage basin as an area that drains from a particular river. So Mississippi River Basin. If we have a drop of water hit somewhere, is it going to empty through the Mississippi River? And like I said before, water in Minneapolis, Minnesota, Pittsburgh, Pennsylvania, Billings, Montana, if it hits any of those places, it's going to empty through the Mississippi River. So we can look at the area, the actual area, or its polygon, or the space that's going to be emptied by the Mississippi River. And we can break those down to, all right, let's look at the Missouri River, which are sub-basins of the Mississippi, versus the Ohio, versus the Tennessee, and the Arkansas. So you can see the examples of these drainage basins. And you can see, the upper Mississippi, the lower Mississippi, the Tennessee, Ohio, Missouri River here, Arkansas red. But this whole area here is going to be part of the Mississippi River, basin here. Colorado River that empty out into the Colorado River going into the Gulf of California here. And like I said before, we've got this Atlantic drainage basin versus in one direction it goes to the Atlantic, the other direction it goes out to the Mississippi. And then we have some that go up to the Great Lakes. So you can see where these empty, but a lot of these, the Mississippi River Basin makes up about a third of the United States. We've got the Colorado River Basin here. I'm going to show some of my pictures from there, but we've got the Colorado River all the way down to the Gulf of California. There's a lot of irrigation where California and other states are taking water from here, so the amount going through this area doesn't equal the amount going out. And then we also have exotic rivers, which are rivers that don't empty anywhere. And the state of Nevada, which is right about in here, has a lot of these what we call exotic rivers. So the drainage patterns can be parallel, associated with steep slopes, dendritic, which look like trees. A lot of these in the eastern United States look like trees that just branch off from each other. Kind of like the Mattaponi River. The Mat and the Ta and the Po and the Ni form the Matta, and the Po-Ni, which form the Mattaponi. We have something called discharge, which is the outflow from a stream. You can see the formula there. We're not going to do too much math with that, but it's measured in cubic feet or cubic meters per second. And when we look at erosion, we have abrasion, the way that it's the mechanical breakdown, and then why it's transported in a solution, which is dissolved or suspended, or jumps, or it's dragged along the bottom by stream flow. So you can just see the different ways that it can be transported, because like I said before, everything in that 1/3 of the United States is going to empty through the water is going to go through the Mississippi River at one point in time. It might be deposited before that if it gets slower or whatnot, but you can see some of the examples here. But the power of water, this fluvial activity wears down mountains. Flood events can move large pieces of rock and material. So you can see some of these kind of exotic pieces to your right here. And then it's got velocity. It's swiftest at the surface directly over the deepest portion. Frictional forces are at a minimum. So, we don't think of water having friction involved with it, but it does. And then we have oxbows, which are meanders which move and pinch off segments of the loop. So there's some really interesting anomalies here, if I can think of it. Go to here. And you can see the Mississippi River has a lot of these, what we call oxbows, where they've been cut off at one point in time. So you can see these oxbow lakes right here. This used to be part of the Mississippi River, and now it's literally cut it off. So now you can see Arkansas. Well, you can see the boundary here. This is Arkansas, but this is Mississippi. Okay, so it's Arkansas and Mississippi don't form at the Mississippi River boundary where this oxbow was, which probably formed in the recent history. Here's another interesting one here. This is Carter Lake, Iowa. Okay. So this is actually part of Iowa, but you can see that it is in the state of Nebraska. Oh, in the state of Nebraska. And this was formed in the 1850s where there was a big flood. And this is where the Mississippi River used to go. And then there was a big flood, and basically it cut off this oxbow, but Carter Lake was part of Iowa at the time. So you can see this interesting geographic anomaly formed as a result of these oxbows and some of these terms that we're talking about. So you can see, especially in the mountains, the stream channel, and this area here is called the floodplain. For a place like the Mississippi River, this floodplain is miles wide. We can see these pools where it's deepest and obviously fastest because of the lack of friction. And then you can start to see this meandering stream development, these cutoffs, and these oxbows. And a lot of these are going to be along slower and older rivers, such as the Mississippi, especially the lower Mississippi. You can see some examples here. Just imagine trying to get an oxbow here. It's going to take a long time to cut through this large rock here. This is in Fairbanks, Alaska. This is in northern Idaho here. This is a picture here at Dead Horse Point up in Utah that I took a few years ago. So I believe this is the Green River, which goes in, meets up with the Colorado River. But you can see this beautiful strata right here. We have a profile. They have steeper slopes that dominate their upper segments, and then they get lower and lower as the stream gets older, or the lower Mississippi. And so you can see this gentle gradient down to its mouth, but the steeper gradient, where it forms. And you can see the relationship between discharge and width. You can see a really good example here in Alberta, up in Canada, Glacier National Park. And they have nick points and waterfalls, so the interaction of water and layers of rock and sediment. We have these in Virginia and the eastern United States, where we have the falls right at Fredericksburg, where we go from kind of the Piedmont region down to the coastal plain region right there. And you can see these nick points and waterfalls are pronounced areas right there. We have in North Carolina, there's the Falls of the Neuse outside of Raleigh, which goes from the Piedmont region, serves the difference between the Piedmont and the coastal plain where it gets extremely flat. And you can just see some more waterfalls here. This is Yellowstone Park here, so you can see this V-shaped valley right here. And then we have stream deposition, stream terraces. And you can see some of the terms that we use to express the floodplains and the related landscapes. We have a delta, which is this triangular shape. You can see the mouth of the Ganges here. And this is in Bangladesh and India. And this is the Mississippi River Delta. And you can see this, where it extends. This is New Orleans right here, and you can see how far it extends out into the Gulf of Mexico, where all this material and alluvium is being deposited out here now. This is the Amazon. And then you can see another one here. This is in Egypt. This is the Nile. This is the Niger in off the coast, Western Africa. And this is the Seine River in France. These just talk about some of the measurements to express these. Three Gorges Dam. This was a big project in early 2000s in China. And you can see people building in kind of these floodplains right here. We'll talk about arid lands. So these are sand dunes. in deserts, which areas which receive little precipitation. This is the Sahara Desert here, about the size of the United States, and then we have the Sahel, which is just to the south here. But you can see the relationships between desert and, you know, human settlement right here, which I think is really interesting. We have some interior drainage basins. I've talked about the idea of exotic basins here, where they don't flow out of anywhere. This is Death Valley. And then we've got some of these exotic streams here, you know, such as the Nile crossing here without a lot of tributaries. This is Lake Havasu. Forms the boundary between California and Arizona along here. This is a picture I took here. This is a little bit further north of Colorado. This is Lake Powell up in Utah. And you can see how much it sunk. This used to be underwater here. But this is formed by the Glen Canyon Dam right here. And this whole lake right here, which was once the Colorado River, and the Green River is now this. And you can see the differential erosion of hard and soft rocks, and I've shown examples of that before. You know, in your dry versus your moist climate, which kind of, we've got a lot of material, soil, things keeping it in place here versus other places. And then Aeolian transportation. Aeolian transport. Aeolian means deposited by wind. I believe there's a Greek god named Aeolus, who it's named for. And then you can see the sand dune migrations, transport. And this is a sand dune outside of Boise, Idaho, about 50 miles southeast of Boise, Idaho. Really neat, that I've been to before. And this is out in Monument Valley.